Okay, welcome June. Welcome to YourPedia Snap channel, MOOC channel. So you have
Thank
an
you.
Snap for RCC subjects, and you have an interview in CPCB, right?
Yes, sir.
Okay, first of all, tell me about the why elastic neutral axis passes through the CG of the body.
Okay, sir. Elastic, sir.
Yes, elastic neutral axis why passes through the CG of the body.
Why?
Why? Yes, why?
E-
Okay. What the difference between the under reinforced section and the balance section?
Yes, sir. In under reinforced section, the steel amount of steel is provided is very less. So steel becomes first failure, and then compression concrete becomes next to the failure of steel. In balanced sections, both steel and concrete simultaneously failure. That is the main difference, sir.
Okay, what type of failure observed in the steel?
Yes, sir. Cup and cone failure.
Cup and cone failure.
Yes, sir.
Are you sure cup and cone failure is there? If you provide the under reinforced section and steel will fail by making this
No,
cup
no,
and
sir.
cone.
No, sir. No, sir.
How will you
No,
ensure
sir.
that steel has failed?
When straining, steel has failed.
As you said, no, in under reinforced section you are providing the lesser steel. So
Yes, sir.
steel fail first, and then after that concrete will fail. How will you ensure that?
Steel is not failing, but amount of strain will increases, sir. So at that particular point, strain will increase particular limit of point. Then we consider it as
What
a
is that limit?
uh, that plastic up to the plastic neutral axis, sir. Sorry, sir, plastic region.
Tell me the value.
Nearly strain in 6 times of strain in elastic, sir.
You are not getting my question. As I am providing the under reinforced section,
Yes, sir.
so how much strain will observed in the steel to fail? If I'm saying that steel has failed, so how
Okay.
much the value of strain is there for the steel?
Yes, sir. 0.002 plus 0.87 Fi by Young's modulus of steel, sir. That
Yeah, I'm
value
asking that. Okay.
gives
Okay. What do you mean by this critical depth of neutral axis?
critical depth of neutral axis. Yes, sir. This it is a center layer. Sorry, sir. Sorry. Critical depth of
Have you heard about this term, critical depth of neutral axis?
Yes, sir. I heard
In
this,
WSM or LSM?
both, sir.
Can you define it? Critical depth of neutral axis. What is that? What type of section it corresponds to?
What type of section?
It corresponds to
It corresponds to many, both three sections, sir.
under reinforced balance section or over reinforced.
Yes. Oh, sorry, sir. Critical section is balanced section for balanced failure, sir. It is a limit. It is that limiting depth of neutral axis, which will uh, that mean we compare the actual depth of neutral axis and critical depth of neutral axis. That's then we will tell under reinforced or balanced or over reinforced. That is the critical depth of neutral axis.
If you are providing the under reinforced section, then depth of neutral axis more than critical neutral axis or less than critical neutral axis?
Less than critical neutral axis, sir. From bottom. From top.
From top.
Yes, sir. Always from top.
Okay. What is the basic difference between the singly reinforced beam and doubly reinforced beam?
In singly reinforced beam, reinforcement provided in the tension side of the beam, and doubly reinforced beam, we reinforcement is provided both sides of the means tension and compression sides of the beam.
Why you are providing the steel as a in compression member, in compression sides or compression zone, you can say?
Yeah, if there is some reasons, if depth of the beam is uh, limited, then we can't increase the depth of the beam. Then we to increase the strength of the beam, we can provide steels in compression zone. If there is another reason, it might be correct or wrong. Uh, Shrinkage, if tension reinforcement only tension reinforcement is there in the bottom side, then shrinkage effect will be somewhat more than if both sides of the reinforcement provided, shrinkage effect will be less.
In what sense you are saying shrinkage effect will be less?
Uh, if only tension reinforcement is provided in shrinkage, when beam shrinks, a tension reinforcement gives compression, but concrete gives uh, tension. There is no compatible in this in the beam. So if steel also provided in compression zone, there is a balance between upper steel and lower steel.
Okay. So tell me design philosophy about WSM and LSM. What is this? We have the three design philosophies: WSM, ultimate load method, and LSM.
Yes, sir.
Explain it.
Yes, sir. In working stress method, we design the beams or any material in RCC. There is an yield stress in any material which yield up to some particular load. In if we design a beam such that uh, less than yield stress, then it is in working. Sorry, sir. It will.
Take a deep breath. Take a
Okay,
deep breath and then start.
yes, sir. In working stress method, we design the beam less than the yield stress that are in material. In limit state method, we design a beams in either in strength criteria or serviceability criteria, which is a limit state.
That's it.
Yes, sir.
What about ultimate load method?
Yes, sir. Ultimate le- ul- ultimate ultimate load method is up to the ultimate point of stress in which gives in any material to failure that that up to that load we design, that is called ultimate load design.
What is the moment of resistance? What is it?
Yes, a moment of it is a resistance due to the cross section of the beam created resist by the given load
How will you calculate it?
by by formulas or bending equation.
Tell me that formula.
M bending moment is equals to stress into modulus of section.
What is it? Modulus of section.
I don't know the definition, but I know the formula for it.
Tell me formula.
It is a ratio of moment of inertia to the neutral axis depth from neutral axis to the top or bottom maximum y max.
Okay, moment of inertia is written about which axis?
It is major axis.
In every situation, will it be major axis or it can be minor axis?
No, sir. Sir, can I guess, sir?
You can.
I think in minor axis will be the correct answer, because minor axis will give less resistance and major axis give more resistance. So we always do for minor axis.
You cast the concrete. You test the concrete as a compressive strength to find out the compressive strength. You test on the concrete cube. Okay, and we know that the results are more than the actual results. What is the reason behind it?
Sir, can I can you repeat the first line of?
You test the concrete
Yes, sir.
as making the concrete cubes of 150 mm on a
Yes.
UTM machine,
Yes,
and you
sir.
get the result. You get the load value, you get the stress value, and you are
Yes, sir.
getting the result more than the actual. What is the reason?
For cube that is a less in size, there is, so we will get more strength, sir.
Why? What is the reason? Less in size means lesser area. Lesser area means more stress.
Yes, yes. Less accession. What is the reason? No, sir, I don't know, sir.
In the same case, you are making the cylindrical specimen, and in the cylindrical specimen, you are getting the results more than actual but less than the concrete cubes.
Yes, sir.
So why is there a variation? In the concrete cube, we are getting the more results. In the cylindrical specimen, we are getting the more result but less than the
Lateral,
cube
that
set.
is lateral buckling. Due to lateral buckling or lateral restraint, there is no restraints
Lateral buckling,
from lateral restraints, sir.
lateral restraints,
Yes, sir. In
lateral
cylinder,
buckling, lateral restraints.
yes, sir. Both are the
Both.
same. Yes, sir.
Okay. Okay, Jivan, let me give you feedback. First of all, देखो, as you have prepared, as you have knowledge, but only little bit knowledge about the concepts, but you don't know the basic concepts behind it. So first of all, revise that concept. Okay.
Okay.
First of all, every question must be clear in your mind. That is not that not seems that every the questions I am asking you that you are not getting my question. So maybe if you get my question, but you are not replying me in that way.
Yes, sir.
So, just as I asked you first question, why elastic neutral axis passes through the CG of the section? The reason behind only simple that if we make a triangular stress distribution as per the bending formula, as per the bending equation we have, we get the triangular stress distribution. In the triangular stress distribution, we know that the moment of area about if I'm moment of area about the CG comes out to be zero. First of all, moment of area about the CG comes out to be zero, and that's why elastic neutral axis passes through the CG. If you want to prove, then you have a flexural equation m by I equal to sigma by y equal to E upon mu r. And if you are making the
Yes,
triangular stress distribution, in the triangular stress distribution, take any y and you will get the sigma. From the neutral axis, take any y. So
okay.
if you are getting the sigma, that means the sigma fx equal to zero. Body is in equilibrium. Then you'll write the sigma fx equal to zero, and sigma fx will be sigma stress into area. That's sigma into dA. Sigma into
Yes,
dA, and what is the value of sigma? You can find the value of m by I into sigma by y. So m by I multiply y into my dA equal to zero. And throughout
yes,
the cross section, you will integrate the whole equation. Integrate करते हो तो m by I will come out. So in the integration, you have only two terms, sigma and dA, y into dA. And integration of y into dA must be equal to zero, and it only is zero about if moment of area is zero only about the CG of the body. So that's why neutral axis passes through the CG of the body. Okay.
okay, sir. Sir,
And
sir, can I, if any interviewer ask derive the proof for the neutral axis will be at CG of the any body, then uh, I write or tell by telling us, sir.
as I told you, no, you'll tell exactly as I told you.
Okay.
What I told you.
Okay, sir.
Can you repeat it?
No, sir. You told the derivation for total derivation.
Make the stress distribution. Make the triangular stress distribution.
Yes, sir.
Let me tell you. You have this stress distribution like this triangular stress distribution, right?
Yes, sir. Yes, sir.
Of any rectangular section, let us assume.
Yes,
And this is the neutral axis.
yes, sir.
This is the d by 2. This is the d by 2.
Yes,
And this is the stress distribution. A body is in equilibrium, so you'll write sigma fx equal to 0. Take any y, you will get the sigma value. So that this sigma fx, so this side is compression, this side is tension, and you will consider the whole area, whole force.
yes,
So
sir.
what is the force? Sigma into dA. Sigma into dA, then
Yes, sir.
integration of sigma into dA will be equal to 0. You have flexural equation m by I, sigma by y, E upon m.
Yes,
So
sir.
I'm writing the value of sigma.
Yes,
M by
sir.
I multiply y into dA equal to 0.
Yes,
M by
sir.
I comes out from the integration. The integration of y dA equal to 0. M by I
Yes,
cannot be equal to 0. So
yes,
integration
sir.
of y dA have to be 0. And it only 0 if this axis passes through, if you are considering the y from the CG of the body. Only 0
Okay, sir.
because the moment of area, this is the moment of area. Moment of
Yes,
area
sir.
is equal to 0 only takes place when you are taking the way from the CG of the body. So that's why
Yes, sir.
elastic neutral axis passes through the CG of the body. Okay.
Okay, sir. Okay, sir.
Okay, next I ask you the difference between the under reinforced section and the over reinforced section. As you said, okay, in the under reinforced section, we observe that the steel will fail first, or you can say steel yield first, because the
Okay,
criteria we have the strain criteria
okay,
we
sir.
use. So steel will yield first. Steel will
Okay,
yield first. Steel yield
yes, sir.
करेगा. The failure criteria is you're saying. So
Okay,
how
sir.
will you ensure that steel will fail? If the steel has a strain value 0.002, as you said, plus 0.87 Fy divided by ES, then we can say the steel has got this value of strain that we can say the strain has failed. But then the
Yes, sir.
compression in the compression of the concrete concrete have a strain that is less than 0.0035. Okay. In the balance
Okay, sir.
section, we say that the strain in the concrete and the strain in the steel,
Steel.
work as a strain, a failure in the failure in the concrete and the failure in the steel will be simultaneously failure observed. Simultaneously failure means strain in the concrete you will get the 0.0035, and the strain in the steel you will get this value 0.002 plus 0.875 by
Okay,
yes.
sir.
Okay, in the balance section. Then
Okay,
I
sir.
ask you the then I
Okay,
ask
sir.
you the critical depth of neutral axis. Okay, critical depth of neutral axis. This is the neutral axis. This is the neutral axis that
Yes.
correspond to the balance section. If we are making a balance section
Okay.
in which we are considering the failure criteria that both concrete and steel fail simultaneously, that means the yield in the concrete is this upper fiber and yield in the strain is this. And if you are
Yes, sir.
considering this criteria, then corresponding to this criteria, whatever we are getting the value of this neutral axis, we will say it is a critical depth of neutral axis, right?
Yes, sir.
Okay, and in the under reinforced section, we get the neutral axis less than the critical depth of neutral axis. Why? Reason being because we are saying that the steel will yield firstly. Then after that,
Because,
concrete will fail. That means that there's a more concrete area above the neutral
yes, sir.
axis. That's why the neutral axis will less than the critical depth of neutral axis. In the over
Yes,
reinforced
sir.
section, neutral axis will be more than the critical depth of neutral axis.
Sir,
Okay.
sir, one doubt, sir.
Yes.
Sir, if CG is the for homogeneous material, it is a center point normally for rectangular beam.
Yes.
If we provide the CG steel in reinforcement in bottom section, that means tension side, CG will be somewhat
Hello.
downside. Hello, hello,
Yes,
sir.
yes. I'm listening. Yes,
Yeah,
I'm
yeah,
listening.
okay, okay. Okay, sir. If reinforcement provided in the beam for bottom section, there will be high amount of area. For that, CG will be must be downside the normal case, sir.
CD will lies downward only when there is a more reinforcement in the tension side. If you're providing a more reinforcement in the tension side,
Yes,
if
sir.
you're providing the more reinforcement in the tension side, that will be lower than the neutral axis
Yes, sir.
here. If you're
Yes,
providing the
sir.
more steel here, if you're providing the
Yes, sir.
more
When
steel here,
you
that means the if listen to me, if you're providing the more steel here, that means more area will be lower than this. More area will be lower than this neutral axis. That means the CG will shift downward. And
yes,
if,
sir.
if it happens, then concrete will yield first. Then it will
Yes,
be over
yes, sir.
reinforced section.
Yes, sir. For that, you
Steel will
asked
more,
that.
steel will more or steel will less. That depends what type of section we have, under reinforced or over reinforcement.
Yes,
On
sir.
that criteria, we are saying that the steel will more or less.
Yes, sir. Sir, for you are asking why for under reinforcement beam actual neutral axis depth less than the critical neutral axis depth. For that question, can I say that more less steel will be there in bottom side? So
Mhm.
uh, actual
Yeah, you
neutral
will say,
axis.
you can
Yes,
say
sir.
that in under
That is my
reinforced
question.
section we are providing the lesser steel,
Yes, sir.
and due to this reason, steel will yield first.
Yes,
Steel
sir.
will fail first. Yeah, we can say that.
Okay, sir. Thank you.
And lesser steel compared to balanced section.
Okay, sir.
Okay.
Sir,
Okay.
yes,
Overall,
sir.
yes.
One more, sir. We cracked sections. I mean, we consider as a cracked section for the bottom for tension reinforcement for tension side of concrete, sir.
Yes.
Yeah, if we there is no calculation for the strength or any contribution in strength resistance for the bottom side of concrete in beam.
Just
Yes, sir.
think it. Can you cast that beam? If you are making only concrete, if you are casting the concrete in compression zone and not in the tension zone,
No, sir. Practically not possible, sir. Sir, am I audible, sir?
yes.
Practically not.
Getting my question.
Yes, sir. Practically not possible, sir.
Yeah.
If
So
any question asked, what can I say, sir? Practically not possible.
yeah,
Yeah.
obviously, na. If the things are not practically possible, then how will you design that?
Okay,
How
sir.
can you design that? You are
Okay, sir.
designing something, but that is not practically possible. That what is the benefit of that design?
Yes, sir. Sir, one more question, sir.
Yeah.
Yeah, I will draw, sir. Sir, for uh, this is actually steel force, sir.
Okay.
FT. This is concrete force, sir. This is CG of concrete. This is steel reinforcement.
Yeah.
FC. This is a for balanced
Yes.
section, sir.
Right.
Okay, sir. For that, this is a uh, it, for under reinforced section. It will be the actual neutral axis depth.
Yes.
Yes, sir. If for the value strain 0.02 for 0.7 F5, there is a limit, sir. This will be the limit.
Yes.
If it increases, we consider it as a fail or
Obviously, boss. Obviously, na. If the strain in the steel has more than the limiting value, then steel will fail.
but there is a scope for steel. We increase this greater than this strain also in steel, sir.
A strain can be more than steel, no doubt, because strain that if the strain in the steel has more than this limiting value, then steel will not fracture. Steel will not
Okay.
fracture. But we assume that the steel will fail. If the values comes out to be more than the permissible values, we will say the steel has failure. Member has failed.
Yes, sir. That means excessive deflections.
Axis deflections. You
Me,
can say axis. You can say that axis deflection. Steel will
yes.
fail. Yes. So the
But
deflection is there.
actually, steel will not fail, sir. Actually,
Fracture. You can say fracture. Actually, steel will not fracture as the concrete fractures. Concrete will
yes.
not yield. Steel will yield.
Okay. Yes, sir. So,
So
how
you can
I
say
what
fracture.
my question is, actually, steel have a more strain value. Uh, 0. More
Yes.
than
Yes. Yes.
there is scope for 0. This value, this limiting value.
Actually, अभी तुमको जीवन क्या करना है कॉन्सेप्ट पढ़ना पड़ेगा यू डोंट नो द कॉन्सेप्ट ऑफ एलएसएम अप्रोच you don't know the concept of WSM approach. First, revise thoroughly LSM approach. Okay,
No, sir.
revise your notes, and after that you will get your answer. Why you are confusing? It's a simple approach.
No,
Just
no, sir.
revise.
I'm asking just this will we assume that steel will yield and that will be the failure criteria for this limiting value. But I'm asking for steel there is a scope. There is a scope for this limiting value. There is also a what I say this sir for
Plastic
plastic
zone you can.
sir for plastic analysis we consider up to the uh, plastic region this region sir.
Yes, yes,
But in this in first 0 to this value is always like this up to
yes,
here only.
yes. Okay, you are
We
asking
assume
that
that
why we are not taking the zone of plastic zone here.
yeah, yes sir.
Okay, consider that zone. If we are considering that zone, the strain in the concrete will be more.
Strain in the concrete. Strain in the concrete. How it will be sir? It will be less always. It will be like this only.
How can you say it will be less like that?
Yes sir. That
Just
means
don't
steel will yield
don't draw
more.
like this. Don't draw like this. Draw like this. Ah,
How?
here, see here. This we have been,
Yes
and
sir.
this we are making this sagging is there. Okay.
Yes sir.
So if tension is if there is just more strain in the tension, then automatically more strain will be the concrete also observed now.
Oh,
Concrete in the compression, concrete in the steam. If it is increasing, then it will also increase. How can I say it will decrease?
okay sir. Okay sir. Strain will always be like this only. Okay. Okay sir. I got it sir. This is actually stress diagram.
Strain
Okay, sir.
diagram and stress. No, it is not a stress diagram as you do. It is not a stress diagram. It is a strain diagram. Stress diagram is for the concrete is like this.
Yes, sir. Sorry, sir.
So
Sir,
as I said you that revise your concept thoroughly first of all. After that you will get your doubts solved clear. You will clear your doubts or as your own. If you have listen, if you have any doubts related to any points, if you have any doubt, then you
okay,
can
sir.
WhatsApp me. You can WhatsApp also Vikram sir also.
Okay, sir.
You can WhatsApp. Okay.
Okay, sir.
Yes.
Sir,
So I'm going to.
if any interviewer ask for why you would not consider this plastic region as in RCC, then what will be the effective answer for that question?
In the plastic zone, we are not going because you can say that I don't know the exact reason, but I can guess that maybe possibility that the strain in the concrete will be more than the limiting value. If I'm going beyond this value, yeah, or if I'm going this in plastic zone, then
Yes, sir.
strain in the concrete will be observed more
Okay, sir.
than the limiting value that we have 0.0035. Maybe this is
Okay.
the reason, but I am not exactly. I don't know. Maybe that can be the reason. Okay.
Sir, yes, sir. And the RCC will be plastic analysis or what is the For because steel will yield
Listen, Jivan, listen,
yes,
all your doubts, you WhatsApp me whatever you have doubts. जितने
yes
भी
sir.
तुम्हारे डाउट्स है मेरे को व्हाट्सएप कर दो, मैं तुमको बाद में बता दूंगा.
Okay sir.
ओके.
Okay, thank you sir.
हो रहे हो, अच्छे से अपने सब्जेक्ट्स को पढ़ो, दोबारा से इस चीजों को समझो. ठीक
Okay
है, कंफ्यूज होने की जरूरत नहीं. डाउट्स आएंगे, जितना तुम पढ़ोगे उतने ज्यादा डाउट्स आते हैं. तो
okay
डाउट्स आने अच्छी बात है, मैं गलत नहीं बोल रहा हूँ, डाउट्स आने अच्छी बात है, डाउट्स आने भी चाहिए, तभी चीजें समझ आती हैं. तो ये पढ़ने से ही होता है. दोबारा दोबारा
okay
पढ़ते रहो, बार बार चीजों को पढ़ते रहो. अपने चीजों को जितनी ज्यादा पढ़ोगे उतने ज्यादा डाउट्स आएंगे, और नोट्स को दोबारा रिवाइज करोगे, डाउट्स क्लियर भी होते रहेंगे.
okay.
ठीक है, चलो.